No.
Okay, I don't know when that cut off, but we'll carry on. Basically, the build will be constructed from a stem wall. So you've got a V trench first. None of this great big floating slab, 18-inch of concrete. Concrete is one of the biggest planet killers in construction. It produces 10% of the world's CO2. So every part of CO2 that's produced will come from the processing or the manufacturing of concrete. Can't take it away from concrete. It is a fantastic material, but if it doesn't need to be used, why use it? We'll have a V trench with rubble and a perforated pipe inside it, probably about 3.5 feet deep. The waste that comes out that, the burden that comes out that V trench will then be reused in the form of cob, which is a mixture of subsoil mixed with straw and water. And basically it's all mixed together, and then you pick it up like a doughy cake, and then you literally use that on the walls, thwack it down with a thwacker, which could be anything from a cricket bat to a shovel. And you can shape it. Incredibly environmentally friendly, obviously, because it comes from the site, so it's very environmentally friendly. One of the main things with cob is you've got to keep it dry. Hi kids.
Chloe Myers is...
Okay. One of the things with cob is it maintains a humidity for human beings, so it's a very environmentally friendly thing. So you shouldn't get lots of colds, coughs, sore throats, and people who have cob houses actually can vouch for that. Another advantage of cob is the thermal mass. The easiest way to describe thermal mass is the energy from the sun will hit the walls. It will then travel through that wall at a period of about an hour per inch. So if you've got a 24-inch thick wall, it'll take 24 hours for that heat to go through the wall. Another thing that's good with cob, apart from the thermal mass, it aids in keeping it cool inside when you want it cool during the day when it's hot, like today. And then during the evening, when the temperature drops, it'll still be relatively warm in the night time. So it kind of works fantastically. On the top of the roof, we should be using sod again, or sedum, which is basically a mixture of herbs and peats and mosses. They're again incredibly good for the environment, because one of the things they will do is prevent runoff. So whereas most of our rain now is all coming in one go, it'll hit the roof and it'll actually be held on the roof and then released with evaporation back into the atmosphere. You can also use them on the sap ratings for your energy, and it'll actually be included in your insulation of that roof. We'll probably be ending up using shiplap boarding, or plywood, which is called, well, I call it donkey's breakfast shiplap, which is loads of different types of chipboard all put together. Put that on the roof and then fiberglass resin on the top, as you'd use for yachting or something. So it'll be yachting grade, so it'll be very good. And one of the main things that decomposes fiberglass eventually is the ultraviolet rays from the sun. So it'll be covered up, so it should last 100, maybe 300 years. Hopefully. I mean, there are cob structures around that are well up to 800 years old around the world, and 2/3 of the world's population live in a mud hut of some description, or a mud home. So the advantages of using that, apart from the cheapness side, cost side of it, you're not bringing stuff in, so environmentally you don't have to worry about transportation. Here's our stream, which we'll be envisaging to use the water from. So an extraction license will possibly be in order. It has been tested. It's come back with a little bit of dissolved nickel and some nitrates, but you're going to get some nitrates. Okay. This is the actual plot. We've got 4 acres of scrub grassland. Feasibility study done was that it was of no scientific interest. Certain people in the Wildlife Trust have said plough it all up and turn it into grass. My whole idea was, if you take 4 acres and build one property on it, well, that's got to be a sustainable way for the habitats down here. If you only use 1/16 of everything that's down here to build on, and the rest of it is left to itself, that's got to be a good thing. We've also planted about 3,500 trees down here to offset any carbon. Get rid of that. Planted 3,500 trees down here, which will get rid of any carbon that we may burn. The ground itself, I've done a few preliminary samples on the ground here, which is very clayey, and very shaly. Basically, a quick test for cob to see whether the ground is suitable is you want some clay but not too much, but you also, the thing that you don't want is silt in it, and you can basically do this by taking the soil, mixing it up in a jam jar with some water and some salty water at that. I have no idea why it's got to be salty water. I think it's possibly to do with the denseness. Shake it up, count it after 10 to 20 seconds, make a mark, then after 10 minutes, and then leave it to settle over the next few days. And basically I think it's the part between the 15 seconds will actually give you a layer of silt, and any vast amounts of silt over there over your through mill, it won't be suitable for making cob out of. But this stuff seems to be perfect, and there is a cob cottage built less than 600 yards away from us, and that's built on dirt. There's no footings, there's no damp course, there's nothing like that. The building rates are fantastic. They've basically just said, as long as I undergo a cob building course, right, part 3,